right. So the other day we talked about how to solve those problems. So remember we had a couple of different, there's a couple of different kinematic equations. And remember, kinematic equations are just what we use when the acceleration is constant, okay, when the acceleration is constant. So remember, they looked kind of difficult because we had all those different variables, but then we just broke it out and was like, oh, we've already used all these variables before. We've already found VI before and VF and A and T and D. We knew what all those were. As a matter of fact, really quickly, as a quick review, let's see. Jalen, can you tell me what A stands for? Do you remember what A stands for? And just unmute so we can go fast if you can.
Acceleration.
Acceleration, very nice. And then Jordan, how about T? Jordan, you there? This Marlon, how about T?
Second.
Say again, T? I'm sorry, I just didn't hear you. Oh, Jordan, were you there?
Yes, just
Okay, what does T stand for? T stands for, I think you said time. I think you did. If you said time, that's correct. If you didn't, it's time. Thank you. Yes. And then Harmony, how about BI?
Isn't that the initial velocity?
Yes, it is. And then Robin, how about VF? Robin, you there? Jessica, how about VF?
Final velocity.
Final velocity, very nice. So am I missing a letter? Oh, D. Anybody got D for me? What's D stand for?
Displacement.
Yes, displacement, very nice. And remember, displacement and distance are very similar. All right, so remember, I'm gonna give you a whole bunch of the numbers. You just gotta figure out where they go, and then we're just gonna solve. So that's all we are really doing. So these were a couple of hints we talked about. If something starts from rest or gets dropped, VI is 0. If it comes to a stop, VF is 0. And then this is a really, hold on. There's my pen here. Can't find my pen. Oh, there we go, annotate. And then the one that I really want you to remember is this one. Remember, anytime you're dropping something, because they may not say, oh, the acceleration was negative 9.8 meters per second. But if they say they're dropping something, that means that acceleration is negative 9.8 meters, okay?
Did you just write on the board?
Say, am I able to write on the board? What'd you say, Lydia? Okay. All right, so.
I said, did you write on the board? Because
You should be seeing, can you see my screen? I'm circling something right now. Are you seeing that? You should be seeing a PowerPoint right now. Is everybody seeing the PowerPoint? Parker seeing it?
it sounded like you didn't anything.
Yes, ma'am.
Okay. Yeah, I'm writing on the PowerPoint. Can you see that, Lydia? Lydia, can you see this? Okay, I don't know what happened. All right, so yeah, so just remember acceleration is always negative 9.8 meters per second squared. All right, so now we worked through, remember the whole thing is like this problem doesn't have VF, okay? So VF is missing on this one. So if we do a problem and they have VF in there, you can't use this problem because this problem doesn't have VF, okay? And then this next one has VF, VI, A, and D, but there's no T for time. So like right here, hold on. Am I going the wrong way? Yes. Have to remember to switch. So right here, time is missing. There's no time in here. So if I give you a problem and you have a time is equal to whatever, 5 seconds. That looks like an S. 5 seconds. I can't use this one because this one doesn't have time. Okay, so that's kind of how we are trying to figure it out. So the other day, we worked through this problem. Okay, and so just to review really quickly, we said a cat from stop. Okay, so anytime you see something like start, stop, drop, you should know that that's something. A car from stop. A car from stop. Okay, so that's probably something. And then it said accelerated at a rate of 5.8 meters per second. And then they also said in 10 seconds. And then they asked us how far did it travel. So those will be our different pieces that we were looking for. Okay, so when we did that, all right, we already did this problem. So I'm just going to go to the next slide so we can get to some new problems today. We figured out that a car from stop, okay, that was our VI. Oh. Okay. Sorry. Here we go. Take your time. Except for I'm on the wrong problem now. All right. Slow and steady. Here we go. A car from stop. That was our VI. It was the 0 meters per second. And then it said accelerated at a rate of 5.8 meters per second. That was our A. And then they said in a time of 10 seconds. That was our T. And then when they asked us how far did it travel, that was our D. Okay. So we looked and we compared that to the two different equations we have, A and B. All right. And so I need an equation that has VI, A, T, and D. Okay. Well, equation B has VF, which we don't have. Okay. And it's missing T. There's no T on this one. So we can't use this equation. So we had to use A because it has D, VI, A, and T. Okay. So this is the one we did the other day. I know I'm going kind of fast, but we did this one the other day. If everyone, remember you have those little buttons. If you go to, I think if you click participants, you have a button that says go slower or go faster. Now I'm going to be honest with you. If you tell me to go faster, I'm probably not because I don't want to lose anybody. But if someone tells me to go slower, I'll try to keep up with that. Okay. So this problem we did the other day. So that's the only reason I'm going faster. But if you need me to go slower at some point, I'll keep it up on this other screen and I'll look there if you tell me to go slower. All right. So then we took that and when we plugged it in, let me clear this, okay? We plugged in everything. You can really think about, if you wanted to, you could really think about, okay, VI, if you wanted to look at this equation, y'all, I'm gonna lose it with this board. I'm sorry. I really am gonna lose it though. Okay, draw, click. If you wanted to look at this and make sure you have everything, if you have like color pencils, you could color code, or you could just say, I need something for D. I need something for VI, something for T. I'm just drawing parentheses. Remember, we could use 0.5 for this. I need something to fill in for A and something to fill in for T. Okay, so that's what we did over here. We filled in 0, this was our VI. We filled in 10 for T. We pulled in the 0.5 for the 1/2. This was our A. And then this was T again. Okay. So we plugged all this in and we got this answer at the end. Okay. Let's start a new problem and let's go slow. Okay. All right. So now, mouse, next problem. All right, here we go. Let's look at this one. Take a couple of seconds. I'm going to read through it. See if you can start on your paper figuring out what you have. Do you have a or VI or a VF or a G or a T or whatever you have? Okay. So I'm going to read through this very slowly. Okay. A cat jumps from the second story from a height of 40 meters. What is the cat's final velocity before landing? Okay. So a cat jumps from the second story from a height of 40 meters. What is the cat's final velocity before landing? Okay. So we need to think about what do we have? Like, do we have, or what are we looking for, or what do we have? So do we, don't change. Okay. Is there a VI? Is there a VF? Is there a A? Is there a D? Is there a T? Now that doesn't mean we have all of those, but that's just all the stuff that we had so far. Does anybody see anything that they know we have for sure? Any guesses?
Is the initial velocity 0?
How did you know the initial velocity was 0? That's an excellent observation.
Was that a rhetorical question or no?
I said you are correct. The initial velocity is 0, but how did you come up with that? Just so people understand how you got that.
Because it says a cat jumps from the second story means it hasn't jumped yet, meaning it hasn't moved, so the velocity is
Fantastic.
0.
Okay, it didn't say he was running and he jumped, but at some point he was not moving. If he jumped from the second story, so this cat jumps from the second story, okay, which means he was probably being still first. So we definitely have a VI. It is 0. You are correct. All right. What else you got? Anybody else?
D is 40 meters.
D is 40 meters. Very nice. Now, here's the one tricky thing. It's 40 meters going which way?
Down.
Down. So here's a little bit, this one's a little tricky only because it is 40 meters. So you are correct. All right, but we're going to put a negative sign here because the cat was jumping down. Okay, the cat was jumping down. So it is 40 meters. You are correct. It's jumping down. Okay. Can somebody tell me either what we're looking for or what we're not going to use at all?
We are
We're
going to use time.
Very nice. We are not going to use time at all. There's no time. There's nothing in here about seconds or minutes. So we're not going to use time at all. So that means we're looking for either A or VF, and whichever one we're not looking for, that means we have the other one. What do you guys think? Let's see. Kaylee, what do you think we're looking for? What are they asking us to find?
The velocity.
Which one? Just be specific. You're right, but which one?
The VF.
VF. So we're looking for VF. So that must mean we should have a number for A, but they didn't give us a number. Why not? Anybody? Aurelia, what do you think? What do we know about this? Say again?
I don't know.
Don't know?
No.
They're not telling us like the acceleration like of the cat falling.
Right, but listen to exactly what you said, Jessica. You're exactly right. They did not tell us the acceleration of the cat falling. Now, why would he be falling? Why isn't the cat falling upwards? What is pulling him down?
Gravity.
Gravity. And what is the acceleration for gravity every single time?
9.8 meters.
Very nice.
squared.
Negative 9.8. Okay. So we're going to remember that number because that is always true. So let's see how we look. Let's make sure we get this right. If we go and plug this stuff in, oh, so we would have to figure out first, okay, we would have to think about which equation we would be using. So let's see. All right, looks like we got our numbers right. We're looking for VF, correct? Oops, sorry. We are correct that we are looking for VF. We are looking for VF. We got our acceleration right and our distance or displacement and our VI. So now we're trying to decide, are we using equation A or are we using equation B? Adelia, what do you think we're using?
B.
Yes, we are definitely using B. We don't have any T, okay? And we've got a VF, so we should use B. Very nice, okay? So let's see what that looks like when we plug it in. All right, I'm gonna clear all this stuff off. Actually, I'll just clear off some of it. All right, so now we're gonna plug in our numbers. So remember, you can kind of do it one of two ways, okay? So you can just say, oh, I need parentheses. So there's a number here, oops. There's a number here. There's a number here that gets squared. There's a 2, a, and a D, all right? VF, that's what we're looking for, so we can leave that blank. We said VI was 0, so I'm gonna plug that in right here. So that's 0 squared. And then we needed a plus, we got the plus sign right here. 2, our A was negative 9.8. So we got, so far we've used all those. We need D. Our D was negative 40, so we plug that in right here. Okay, we've used that. So 0 squared is always 0. So this is still equal to 0. On here, I did, if you're looking at this, I'm going to put it in yellow. This right here, okay, that's the same thing as saying 2 times negative 9.8 times negative 40, okay? And when I put that in my calculator, I get 784. So 0 plus 784 is 784. Now here's the weird thing, okay? This says this 784 is equal to VF squared. I don't want VF squared. I just want VF. So for us to get rid of a square root, what we have to do is take the square, for us to get rid of this squared right here, we have to take the square root of both sides. So it's kind of like, if you're trying, it's like the opposite operation, okay? So for me to just say square root of VF squared just means that this goes away. So that's why it looks like this right here. But if I take the square root of this side, I also have to take the square root of this side. So in your calculator, you will put in square root of 784. And when you put that in your calculator, you should get 28. Okay. All right. So we probably, let's just look through this next one. How about we look through the next one? And then for homework, I'll send you a screenshot and I want you to work through that one. Okay. So you got about 2 minutes. Let's look at it. Let's see if we can set it up at least. All right. Questions on that one? Okay. All right. Let's go to this next one. Next. All right. So this one says a hot air balloon travels a distance of 50,000 meters across the sky in 30 seconds with an initial velocity of 550 meters per second. What is its acceleration? Now, be careful here. They did not say the balloon is falling, so we can't just say the acceleration is negative 9.8. It's still up in the air, okay? So what I would advise you to do, and this is how we're gonna finish out class, okay? See if you have, do you have a VF or a VI, a D, or a T, okay? And then I want you to figure out if you're gonna, which of those two equations are you going to use, okay? So let's try to see if we can at least get these variables. So what about let's see. Do we have a, well, this is the first thing that I would look at. What are we looking for?
The acceleration.
Acceleration. So we're definitely going to have something there. Okay. So acceleration we're going to use. Okay. What else did they give us? Robin, do you see anything else they gave us? When you
The
read that,
initial velocity.
okay, we got an initial velocity. Yep. So we got initial velocity here. Robin, do you see what else they gave us? So 550. What else do you read they gave us? Are you putting in the chat? I missed it. Hold on.
They gave you distance.
They did give us distance for sure. And Robin said in the chat, they gave us time. So yes, so they gave us time right here, which is 30 seconds. And then I think that was a really said they gave us a distance of right here, 50,000. All right, so that means we are not going to use at all this one right here, no VF, okay? So really quickly, this is what you're gonna have for homework, okay? I'm gonna send you this screenshot. So now you're gonna figure out, this is your homework, okay? Your homework is to figure out, are we using, and some of you probably already know, are we using this one or this one? That's one step in your homework. And then once you figure out which one we're using, plug it in and see if you can solve and figure out what A is. So I'm going to take a screenshot and send this to you. This is your homework, okay? I will see you guys on Tuesday. Okay? Sounds. Bye, guys. See ya.
Bye.
Bye.